4.8, use a quadratic formula and the discriminant. In this lesson today, we're going to be talking about the quadratic formula, which you know is minus b plus or minus the square root of b squared minus 4ac all over 2a. And this is what x equals if we have an equation of the form ax squared plus bx plus c equals 0, then our solution is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So again, let a, b, c be any real numbers such that a does not equal 0. And again, I can't have a equal 0 because otherwise this wouldn't be a quadratic. It would just be a linear equation. So the solution is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And so in the last section, we did all this grueling work with completing the square in order to find the solution to a quadratic. Well, now I'm giving you a formula which will solve the quadratic. Now this comes from completing the square, and we will derive this equation at the very end of the lesson if you want to know that. So I'm just going to write the quadratic formula right up at the top. You do need to know this formula. And so in this example, I have to first set it equal to 0. So I get x squared minus 5x minus 7 equals 0. Then my a would just be what's in front of the x squared, 1. My b is what's in front of the x, which is negative 5. And my c is the constant term, which is negative 7 in this case. So I have x equals negative b, 5, plus or minus the square root of negative 5 squared is 25, minus 4ac all over 2a, which is 5 plus or minus root 25 plus 28 all over 2, or 5 plus or minus root 53 all over 2. And that is my final answer. I can't take anything out of root 53. So I have two answers there, 5 plus root 53 over 2 and 5 minus root 53 over 2. But this is a fine way to write it. In this equation, my first step is going to be to set it equal to 0. So I'm going to scoot the 17x over here. 16x squared minus 40x, and scoot the 25 over here, plus 25 equals 0. I will make my a what's in front of the x squared, my b what's in front of the x, which is negative 40, and my c is just that constant term, or 25. So x equals negative b, which is negative a negative 40, or positive 40, plus or minus the square root of 40 squared. 40 times 40 would be 1,600, minus 4ac all over 2a. And so I get 40 plus or minus root 1,600. Let's see, that's 100. 100 times 16 is also 1,600 all over 32. And so 1,600 minus 1,600 is 0, and root 1,600 is 0. So I just have 40 plus or minus 0, which I don't need, over 32. And I could simplify that, divide by 8, and I get 5, divide by 8, and I get 4. So in this answer, I only have one solution, and that one solution is 5/4. Let's try this one. A is 1. B is negative 6, C is 10. So I have x equals negative b plus or minus the square root of b squared, that's 36, minus 4ac all over 2a. And so I have 6 plus or minus root 36 minus 40 is negative 4. Okay, now I know how to deal with a negative under the radical because that's just imaginary. I can take the 2i out of this, and so I have 6 plus or minus 2i all over 2. Now I look at each of my terms, the 6, the 2i, and the 2. Is there anything in common in all of those? The answer is yes, there's a 2 in common. I could divide each and every term by 2. So I do 6 divided by 2 and I get 3, plus or minus 2i divided by 2 is just I. That is my answer. Again, I have two solutions, 3 plus I and 3 minus I. The discriminant is defined as, in the quadratic formula, what is underneath of the radical. So when I have x equals negative b plus or minus root b squared minus 4ac all over 2a, the discriminant is just what is under my radical sign. In other words, it's just the b squared minus 4ac. And you might have noticed, let's just look back, our first example, we got two real solutions. And notice that what is under the radical was a positive number. When I have a positive number under the radical, I have two answers because I have 5 plus that number, 5 minus that number all over it. When, however, what's under the radical is equal to 0, as in this case, I only get one real solution. And that's because I, in this case, had 40 plus or minus 0, which is just 40. So I only got one solution here. And the last case was this one, where I had something negative under the radical sign, in which case I got two imaginary solutions. So if my question is just, how many solutions do you have? All you have to do is look at the b squared minus 4ac part, and you know if that is positive, that means you have plus or minus, which would give you two answers. If that equals 0, well, plus and minus 0 is only one thing, because plus 0 is 0 and minus 0 is also 0. So I only have one solution there. And if it's less than 0, then that would mean that this is an imaginary number and I would have no real solutions, just imaginary solutions in two of them. Now, what does it look like on a graph? What does all this mean? If I have two real solutions, remember, I'm looking at quadratics and I'm saying, when does it equal 0? Equal 0 mean, when does y equal 0? Because normally I have the equation y equals ax squared plus bx plus c, so I've replaced the y with a 0. That's basically saying, where does it hit this axis? Because this is when y equals 0, right? And so, if I have the two real solutions case, it just means that it hits twice. If I have one real solution, it means it only hits once. And if I have no real solutions, two imaginary solutions, it just means that it never hits the axis. So it could look like this. Another scenario would be that it looked like this. That would also be a possibility. Another possibility of this would be that it looked like this. Another possibility of this would that it was upside down and hit it twice. Okay? Find the discriminant of the quadratic equation and give the number and type of solutions of the equation. So again, all we need to look at is the discriminant, and that is just what is under my radical, or the b squared minus 4ac part. Determine if it's positive, negative, or 0. So in this one, I have b squared is 100 minus 4ac. So I have 100 minus 92, or 8. 8 is greater than 0, therefore I have two real solutions. In this one, I have b squared is 100 minus 4ac, which is 100 minus 100, or 0. So since I equal 0, therefore 1 real solution. In this one, I bet you can guess what type it's going to be, but let's do it. B squared minus 4AC. And so I have 100 minus 108, or negative 8. Negative 8 is a negative number, therefore 2 imaginary solutions. Now, we modeled an object that was just being dropped from a height before, and we said that the height was equal to negative 16t squared plus h naught, where h naught is the initial height, which I labeled here. And this has to be in feet, and the velocity has to be in feet per second for this equation to work. And again, that's because of gravity. Now, one more equation that you're going to learn, and again, you don't need to memorize this, is h equals negative 16t squared plus v naught t plus h naught. And the v naught is just the initial velocity that I'm throwing it at. So this is just a case where I'm throwing an object instead of just dropping it, in which case I would have no initial velocity if I just dropped it. A basketball player passes the ball to a teammate. The ball leaves the player's hand 5 feet above the ground. So that's going to be my initial height, 5, and has an initial vertical velocity of 55 feet per second. So my initial velocity is 55. The teammate catches the ball when it returns to a height of 5 feet, okay? So the final height, because that's where she catches it, is h equals 5. How long is the ball in the air? So basically, they threw it, it went like a parabola, and it came back down to the same height that it started at. All right, so we need to know how long this ball was in the air. Let's start with writing our equation. So our final height equals negative 16 t squared plus v naught t plus h naught. Our final height is 5 equals negative 16 t squared plus 55t plus 5. And so the first step is always to set it equal to 0. And look, that's going to conveniently just cross out. So negative 16t squared plus 55t. In this problem, it is actually completely unnecessary to use the quadratic formula, but I'm going to use it since we are doing this lesson. So I am just going to do negative b plus or minus the square root of b squared. So 55 squared is 3025 minus 4ac. And c is just 0, right? My constant here is just 0. Okay, so that's going to be nice for us, all over 2a. And so I have negative 55 plus or minus, well, I know the square root of 3025, because this is just 0, is 55, because that's how I got it, all over negative 32. And so I have two answers here. I'm just going to go up here, actually. So I have t equals negative 55 plus 55 all over negative 32, or t equals negative 55 minus 55 all over negative 32. And so this is just going to be 0, or this is going to be negative 110 over negative 32, which equals 3.4375. And these are both in seconds. So why do I have two answers? Well, at 0 seconds, the height is at 5 feet because that's where it started and it returned to the same place. And after 3.4375 seconds, it's also back at 5 feet. So when they ask me how long is the ball in the air, obviously this is just my initial. So my answer is just after about 3.4 seconds. Finally, we're going to derive the quadratic formula. If you have no interest in doing that, then that's it for this lesson. Bye. Otherwise, if you want to hang around, let's go ahead and derive this. So start with this ax squared plus bx plus c equals 0. And I want to complete the square. So I'm going to scoot the c over here. So I have ax squared plus bx equals negative c. And so remember, I said before you start completing the square, you need to have a 1 as a coefficient. So I need to factor that a out. Now the tricky thing here is that I'm going to be left with x squared plus b over a because I factor an a out. And that's that. So now my b is, and this is going to be a little confusing because I'm reusing the letter, it's b over a. And then my b over 2 is going to be b over a over 2, which is just b over 2a. And then b over 2 squared is going to be b over 2a squared. Just going to put a squiggly there so you don't get confused with the same letter. And that square the top, which is b squared, and I square the bottom. So 2a times 2a is 4a squared. Okay, so that is what I'm going to add. X squared plus b over a x plus b squared over 4a squared equals negative c. What did I add to this side? I added a times b squared over 4a squared, right? I added an a times this. That was like my little side. All right, so continuing on. A times, I could factor this into x plus the b over 2, b over 2a, the quantity squared equals negative c plus one of those a's cancel out with one of these a's, so I'm left with b squared over 4a. Okay, now I've got to get a common denominator on this side. So rewrite that. And my common denominator here would be the 4a. So how did I get from, this is a 1, right? How did I get from the 1 to the 4a? I have to multiply by 4a. So I'm going to do negative c times 4a plus, well, this was already a 4a, so I don't have to do anything to the top. Okay, let me rewrite it over here. I have a x plus b over 2a squared equals negative, I'm just going to say negative 4ac plus b squared all over 4a. And now I have to divide both sides by a. So I'm going to divide by a, and I'm going to divide by a. And instead of writing divide by a, isn't dividing by a the same thing as multiplying by 1 over a? So I'm just going to do that over on this side so I make my life a little bit easier. So those cancel out, and I'm left with x plus b over 2a, the quantity squared, equals, let me just rewrite this as b squared minus 4ac, all over 4 times a, which is 4a squared. And now I'm going to take the root of both sides. So I'm left with x plus b over 2a equals plus or minus root b squared minus 4ac. And when I take the square root of the bottom, the square root of 4 is just 2. And the square root of a squared is just a. And now I'm just going to subtract the b over 2a to this side. So I get x equals negative b over 2a plus or minus root b squared minus 4ac all over 2a. And if I just wanted to get that one common denominator, that is what I have. So that's the proof. I do not expect you to understand this at all. I just think that some of you might have thought that was kind of cool. And that's it for this lesson.
Bye.